use of spatial representation in living beings and their ability to forage with very little information in broad landscape is the inspiration for the project. Here you can see an A-life being trained to traverse a 3D maze, and he is using very limited sensory observations, and also you can see the maze is quite complex. This is done using reinforcement learning, and you can see several agents are being trained parallelly, and they all are using a different maze, and they are all being trained on a different random generated maze. Also, we can see that the the agent has very limited information about the environment, and also it is not aware of the food in the maze, because the food is generated at a random location. So this being a sparse scenario, it is going to be very difficult to train the agent uh, with enough generalized information about how to traverse the maze. However, as you can see, the agent has already explored quite a lot of maze, and it is able to uh, associate the reward. So the reward function tells the agent that by collecting food inside the maze, it will get better rewards, and it will have to do it very quickly. As you can see, the as this is reinforcement learning, every state is a new state, and they believe that information of the previous state already exists in this state. However, that is not the case, and we would really need some kind of recurrent neural layer. As you can see, that there have been attempts made in the past where they've provided where researchers have used CNN, and they are able to uh, uh, do screen recording, or they are able to send the image of the maze to the agent, and the model learns from the images, which is not a very good approach, I believe. So, what I'm trying to say is that the agent is able to traverse a very complex maze with very little information. Let's see, let this episode end, and it would be a random maze. So you can see they all are having a random maze, and they all have explored some part of the maze, and they are being trained in parallel. So this agent has been able to explore quite a lot of the maze, but you can see it's very complex. There is no possible path from where the agent is to where the food source is. So he has to go all the way from this location to all the way till the end. Also, we can Here we look at the TensorBoard data, which shows the cumulative reward. As you can see that we have a really nice graph for the cumulative reward. This is one of the previous runs, and the one that we just ran was incomplete. So, but you can see that it will also convert. So, so I can go into the detail of the cumulative reward. As you can see, it is slowly increasing, and then it kind of stabilizes as it's able to understand what the reward function is telling it to do. And we can also look at this the value estimate function, wherein it tries to estimate what its next action is going to be, and it sees that the final reward that it gets. Based on that, the graphs are done. We can also look at the performance inside Unity. As I've just added the half-built training that's completed. So like a few, it learned a few parameters. So let's just test it. As this is in parallel, I'll just disable the other um, agents, so that we can check the performance of how the agent will perform in one game when the agent is embedded in a simple game like this. So let me open the profiler. So as we can see, the agent is taking several decisions, and initially, because it was building, it took time, but then we can see the speed, we can see the rendering has come down below 33 frames per second, and also there is hardly any scripting used. If we disable rendering, there is no physics being used, there's no GPU being used at the moment, but we can see in one of the parameters. So it's 0.7 milliseconds. So it's not even 1 milliseconds of scripting time. So the compute time is very, very low because it doesn't have to do a lot of calculation. And even if we extend it to uh, 8 or 9 agents, as you can see, there are total 9, and each having a different maze. So even if we do have to do that, enable all of them, the the performance the performance is still quite green. It's not too bad, and there is hardly any summation of scripting. As I am doing screen recording, it's possible that there is some lag, but okay. So I have made some more runs, but I guess we can do the comparison. So I can show the previous runs and the issue that I faced. So you can see that even though the agent seems to be learning at the end, after several thousand steps, it would not train very well, and this could be because there is some error, or there is not enough information, or the formulation of the reward function is not being able to associate with the reward. As you can see, I've just run the training again, and it's able to collect the reward. Right now, it's because it's the initial training. As they are training in parallel, it will not log the summaries, but it will log at 90K. So, I mean, we can just see how the agent is able to train. Let's hope this training episodes end. So in terms of the achievement for this project, I would say that it is using PPO in TensorFlow, which is algorithm for associating. So the difference between the strategy that it chose earlier and the next strategy that it will choose is not very large, and it's able to train. I can talk about the training parameters as well, but we can probably look at another agent who is trying to chase rewards rather than being stuck in one side of the maze. So this one is probably is chasing this reward. So it's trying to explore much of the maze and also trying to chase. As this is just the starting of the training, it would take some time to for agent to learn. But as you can see, it has already collected 5 rewards of out of 10. So this is about it. This is my project, and I would be submitting the thesis report together with this. Thank you.